Watch this. This is a magical substance called hot ice. Yes, hot, because it heats up to about 60 degrees Celsius. And if you dip your hand or even just a finger into this liquid, it actually feels really hot. Just a tiny bit is enough to trigger instant crystallization. And thanks to that, we were able to perform some incredible experiments with this liquid. So what is this thing anyway? Hot ice. Scientifically, it's called sodium acetate, and you can easily make it at home. All you need is acetic acid and baking soda. I'm using 70% acetic acid. This concentration works best, and I'll explain why. But first, since my acetic acid is concentrated, I put on rubber gloves and safety goggles to avoid chemical burns. Safety comes first. Alright, I place an empty glass on the scale, turn it on, and pour in the acetic acid. I got 162 grams. Let's remember that number. Now I open a box of baking soda and pour it into a bowl. The mass of the baking soda and the 70% acetic acid should be roughly equal. So we use a 1-to-1 ratio. That's why 70% acetic acid is ideal. If your acetic acid has a different concentration, any artificial intelligence can help you with the calculations. Here are the calculations for the most common concentrations. Next, we need a pot, preferably a large one, because the reaction will happen inside. To keep the reaction from getting too vigorous, we'll dilute the acid with water. You can add about the same volume of water as the acid. I pour the water into the pot, then the acid, and move it to the stove. Since acetic acid has a strong smell, I'm turning on the exhaust fan. Or do this in a ventilated area. Or better yet, outside. I add the first spoonful of baking soda. Look at that reaction. Tons of foam forming. Those are carbon dioxide bubbles being released along with sodium acetate. So I add the soda gradually to keep it from overflowing. Okay, I add the rest of the soda and wait for the reaction to finish. This can take 2 hours or more. By the way, about 60 seconds after stirring, a really interesting effect happens. The foam rises to a certain level and then suddenly collapses. Watch again. It looks awesome. Alright, I close the pot with a lid and leave it alone. After an hour, the foam almost stopped forming, but the reaction was still going, so we wait a bit longer. A couple of hours later, I came back and saw that the reaction had stopped. The liquid wasn't perfectly clear, but we'll filter it later. And look, sodium acetate crystals have already formed on the sides of the pot. Let's scrape some off and set them aside. We'll need these crystals later. I take several layers of folded gauze, then use them to cover this container and pour the solution from the pot through it. A dark sediment stays on the gauze. Looks like there are some impurities in the baking soda or the acetic acid, or maybe in both. That's why you can't get a perfectly clear solution this way. But at least I filtered out the worst of it. I'll dump out the leftover soda and wash the pot. I think if you filter the liquid through a denser paper filter, like a coffee filter, you can get a pretty decent result. So, I pour the filtered solution into a clean pot and place it on the stove over medium heat. We need to bring it to a boil and evaporate the excess water. Right now, the liquid takes up about 1/3 of the pot, but how do you know when to stop evaporating? Just turn off the heat from time to time and check whether a crust forms on the surface. If it appears almost immediately, the solution is concentrated enough. Look, even after I remove part of this crust with a spoon, the surface quickly tightens up with a new layer. Now I pour the solution into a glass container and make sure to close it with a lid. We need to cool it down at least to room temperature. That's when liquid sodium acetate becomes unstable and can undergo instant crystallization. And here's the sodium acetate powder I bought from a chemical store. But this specific powder is sodium acetate trihydrate. It already contains the necessary amount of water. Its formula is on the screen. If you heat it up and melt it, you'll get a ready-to-use hot ice solution. Look how clean and transparent the liquid is, just like water. Much better than the first method with baking soda and acetic acid. I put this jar into the fridge, and the first one has already cooled down, so let's see what we've got. And here are the crystals from the sides of the pot. Let's take a pinch. Drop it into the jar, and the crystallization reaction starts instantly. The entire liquid turns into a solid crystal mass in no time. Right after the reaction, the mixture is slushy. It hasn't fully solidified yet, and now we can quickly return it to a liquid state. Just place the jar back into a water bath and melt it. Done. Let's cool it down again for more experiments. Now let's see what happens with the sodium acetate from the chemical store. I take it out very carefully. The liquid is unstable. I still have some of that powder left. I take a few grains, drop them into the jar, and enjoy the show. The crystallization here is denser. Looks like this solution is more concentrated. And look, the crystals on the surface formed beautiful white patterns. And they hardened pretty quickly. Wow, look at that! The crystals formed beautifully on the pine branch. Next up is a chili pepper, just as hot as this ice. Kids especially love watching this science magic. But be careful, don't let children stick their fingers into it, and don't leave them alone with the liquid. What do you think will happen if we dip this cactus into sodium acetate? Let's find out. Here we go. I think it turned out really cool. What do you say? Now I want to dip a single crystal deeper into the solution. For that, I'll need a sewing needle. Look, a crystal stuck right to the tip. Let's lower it in. Wow, absolutely stunning. This looks even more impressive than dropping a crystal onto the surface. And in this attempt, it even formed a sphere that kept growing in size. If you try this yourself, people around you will definitely be shocked. Here I drop a tiny crystal on top. It looks just as mesmerizing, like an iceberg forming beneath the surface of the ocean. I got curious what would happen if I blew into liquid sodium acetate through a straw. Well, you saw it yourself. Everything crystallized instantly. But don't try this at home. You really don't want to accidentally swallow anything. Let's keep going. I sprinkle a few crystals onto a small plate. Now I'll pour liquid sodium acetate over them. Watch what happens. Look at this icicle forming when I pour the liquid in a thin stream. But it looks like it couldn't hold its own weight and toppled over. Here's why. When it first forms, it's still soft and fragile. But this icicle here, I didn't touch it for a while, so it had time to harden. Beautiful! I pour a thin layer of hot sodium acetate onto a dish and cover it. I wait for it to cool. Now watch the center closely. Share your thoughts in the comments. If you wait a bit, hot ice solidifies. And it really does look like ice. I took it out of the dish and it broke into pieces that looked like slices of pizza. Now I'll repeat this experiment from that angle. But that's not all. Let's keep going. Now let's coat a coin in powder and drop it into a glass. We managed to trigger crystallization at the bottom. Look at this. Doesn't it remind you of something? Looks a lot like snowflakes, right? The coin isn't even visible anymore, but that's okay. We'll melt the crystals and take it out. We decided to repeat this experiment again, but in a bigger container. Ready to be amazed? Wow, Incredible! Because there were so many grains on the coin, crystallization started along the entire height of the vessel. And yes, every time, the solution heats up a lot because this reaction releases a large amount of heat. Look at this fresh, crisp lettuce leaf. And now look what happens after dipping it into sodium acetate. Oh, looks like it didn't feel too well. From a firm, fresh leaf, it turned into an amoeba. Let's check the temperature. Now it's clear. You can't exactly cook lettuce in it, but 58 degrees Celsius is still pretty high. You can't see it on camera, but after I dipped my fingers into the crystals, I immediately ran to wash the sodium acetate off. It was very hot. Even after you pull your fingers out, the solution keeps heating your skin until you wash it off. And keep watching, you'll see me dip my whole hand into the solution. These are chemical hand warmers. They're filled with liquid sodium acetate, just colored in my case red and yellow. Look, inside there's a little activator that works kind of like a hair clip. When you press it, it clicks, and that click triggers crystallization. The warmer heats up instantly. Super convenient to take with you in cold weather to warm your hands. It heated up to 59 degrees Celsius and will stay warm for about half an hour. To reactivate it, just put it into hot water. The sodium acetate inside melts quickly, and you can use the warmer again. I decided to make my own hand warmer, but bigger. For that, I took a Ziploc bag. Hopefully the solution won't leak. Let's find out. I pour in the crystals. A lot of them. I want a hand warmer big enough for several people. I close the bag and place it into hot water. I'm not bringing the water to a full boil so the bag doesn't melt. All right, it's ready. Let's take it out and check if anything leaks through the zipper. Perfect, great Ziploc. Even when I flip it over, nothing leaks or spills out. But how do we trigger the reaction inside? I already mentioned that the activator in the small hand warmer works like a clicking hair clip. So let's use one. I drop it into the bag, squeeze out the extra air, and seal it. Here's the hand warmer I made. Let's set it aside to cool, not in the fridge, just at room temperature. Now let's measure the temperature before activation. It shows 33 degrees Celsius. I click the hair clip, and the process begins. And of course, our hand warmer heats up instantly. Look at that! Wow, 65 degrees Celsius. Honestly, it's even hot to hold. But let's be honest, you wouldn't take something like this on a hike or a fishing trip. The risk of the bag tearing is just too high. So what if we use something more practical? I decided to pour the sodium acetate into a plastic bottle. I screwed the cap on and put it in the fridge. Right now, the liquid in the bottle is at 26 degrees Celsius. But how do we trigger the reaction through plastic? You can't press a hair clip inside like with the bag. No matter how hard I shook it, crystallization wouldn't start. I tried dropping a pine needle in, but just like with the twig earlier, it didn't help. However, when I unscrewed the cap, crystals formed on the bottle's threads. After I closed the cap again and shook it, the reaction started instantly. The temperature rose to 61 degrees Celsius. This is already a much more practical hand warmer to take outdoors than the bag. As I mentioned earlier, dipping my fingers into hot ice was very unpleasant. One finger I could tolerate, and it even looked beautiful. But dipping my whole hand, honestly, I was scared. And sure, 60 degrees Celsius won't give me burns. But trust me, it's not the same as dipping your hand into water. Even after you pull your hand out, the hot ice left on your skin keeps heating it until you wash it off. But I found a solution. I decided to make the solution less concentrated. I poured concentrated sodium acetate into a glass, marked the level with a marker, and added a bit of hot water. After cooling, I take it out and test it. Crystallization still starts, but it's still pretty hot. the temperature reached 49 degrees Celsius. I melt it again and add more water. Testing. Now crystallization happens much slower, but it still works. This level of heat is something I can already tolerate. Look at this, the mixture stays much more liquid. You can see there's excess water. And the temperature isn't 60 anymore, it's a comfortable 45 degrees Celsius. So, with 4 centimeters of concentrated solution, adding about half a centimeter of water, roughly 1/10, is enough to reduce the activity and crystallization temperature of sodium acetate. Well, the moment has come. I'm going to dip my whole hand, but without crystals, the reaction won't start. So, I dip my fingers into the powder first. Here we go. The reaction starts, and it looks really cool. Since the solution was well chilled in the fridge, I felt only a mild warmth. It's nothing like dipping my fingers into the concentrated solution. And the temperature rose only to 30 degrees Celsius. All the experiments I did with hot ice, I'll probably upload them in a separate video so you can watch these reactions in real time. You'll find a link in the description. And now I'll tell you about a few important details you need to know to make everything work perfectly. First, always close the container with a lid before cooling the liquid solution. Otherwise, crystallization will start from the crust that forms on the surface. Second, wipe the rim of the jar with a damp cloth before closing it. There shouldn't be any sodium acetate left on the edges, otherwise crystals will form there and may fall into the liquid. As soon as you open the lid, the reaction will start instantly. Even better, pour the solution into a clean jar and close it with a clean lid. Third, pour the solution into the container you want to use for the experiment while the sodium acetate is still hot. If you pour it after it cools down, crystallization is much more likely to start immediately. And if you pour the solution onto a cold plate, even hot solution will start solidifying almost right away. Apparently, the edges of such a thin layer cool extremely fast and become unstable. That's why I had to heat the plates in the microwave before pouring. Fourth, when the solution has cooled, open the lid right before the experiment. Even a tiny dust particle falling onto the surface can trigger the reaction. Here, I didn't even have time to start recording after removing the lid. The reaction began on its own. 5. Right after the reaction, you can melt the crystals again pretty quickly. But if you let the solidified solution sit for 15 minutes or longer, it hardens completely, and melting it back into liquid can take as long as melting the dry powder. Usually around half an hour, depending on the volume. Now you're ready. With this knowledge, everything will work perfectly for you. To avoid making this video too long, I decided to create a second part about hot ice, where I'll continue experimenting with this amazing substance, color it in different shades, and make a giant multicolored icicle. So if you already see the thumbnail in the center of the screen, click it to go to part 2, and if not, make sure to subscribe and hit the bell. Also, write your ideas for more hot ice experiments you want me to try. See you soon!